Today's lesson is for Wednesday, October 19th, 2011, and today we're going to be going over a PowerPoint on Newton's second law. These are going to be some more advanced problems than what we've gone over in the past, specifically because we'll be addressing objects that are undergoing forces in two dimensions, not just one. So we'll have to get the net force in an x direction and a y direction. After we conclude this PowerPoint and go through some example problems that you can access right here at this link, we're going to go ahead and talk about online aware training. You're all going to be able to take online tests using this new system called Aware, and I'll be showing it to you. I like it a little bit better than Cinch in terms of delivering tests because I can actually modify the tests a little bit more. It also gives me the results in an easier to read format for me. And I think you'll find that on your end it's pretty much the same. So I'm going to be giving you your passwords for that and going over how to use it in the second half of today. Now, over here, if you click on the PowerPoint, let's go ahead and start the notes. So again, these are over Newton's second law. They're a little bit more advanced because we'll be discussing force in two dimensions. The important thing to know about force in two dimensions is that you're going to have to calculate the net force in an x direction and a y direction. So the net force, or the sum of all forces in x, same thing as net force, is going to be the net force for all objects along the horizontal. Okay, so there's going to be left and right type forces if you were to draw them on your paper. The sum of all forces on the y will be the net force of all objects along the vertical axis up and down. So if we're looking at a graph, we're basically talking about a situation where, if you're looking at a coordinate system here, x, y, this would be your x and this would be your y. So the sum of all forces on the x will be the forces that are going left and right, and the sum of all forces on the y will be the forces that are going up and down. Remember, again, we did discuss the fact that when we go up, we'll consider the forces that go up positive. We'll consider the forces that go to the right positive. We'll consider the forces that go down negative, and the forces that go left negative. Okay, so knowing that, we're going to have to use something called the Pythagorean theorem, and hopefully you've used this in math before, but just a quick review over how it's used. The Pythagorean theorem is used when you have two sides of a right triangle. So remember, right triangle is a triangle that has 90-degree angle. So let's look at this triangle as an example. So when you have a triangle that's a right triangle, we can use the two legs of the triangle, and they'll be represented as A and B here. And if we square those and add them together, we can get the square of the hypotenuse, C. So in this case, we'll be using the sum of all forces in the x as our A value, the sum of all forces in the y as our B value, and it's going to give us our hypotenuse, which is the resultant vector, or the net force for all these objects. So that's going to be really important today, that you understand how to use the Pythagorean theorem. Again, A squared will be for forces that are going left and right. So when we get the sum of all forces in the x, that'll go in for A. And then for B squared, the B here, the leg for B on the triangle, will be from the sum of all forces in the y direction. Okay, so let's go ahead and take a look at a problem where we're going to have to use this information. So it says there are four little boys pulling on the corners of an oversized compass. The boy to the north pulls with 10 newtons of force. That's 10 newtons of force. The boy to the south pulls with a force of 6 newtons. The boy to the east pulls with 16 newtons. And the boy to the west pulls with 13 newtons. So if we were to fill these in, this would be our given information right here. The force to the north would be equal to the 10 newtons. The force to the east is equal to 16 newtons. The force to the south is equal to 6 newtons. And the force to the west is equal to 13 newtons. Alright, there was no other given information. They just want to know what the resulting net force is. Again, we have unbalanced forces here. In two dimensions, not just one. Up and down, they're unbalanced. This is 10, this is 6, so they're not even. And then over here, this is 13, and this is 16, right? So the unknown here is going to be the net force the equations that we're going to use for net force, I just explained that when you have unbalanced forces in two dimensions, we'll be using the Pythagorean theorem. So we'll go ahead and write that in. A squared plus b squared is equal to c squared. And you all know that the sum of forces in the x direction, we talked about this in previous days, is going to be equal to Fe, the force east. Again, we're looking at only the forces on this x-axis. And we're going to add the negative of the western force. And then the other thing that we'll have to calculate here is going to be the sum of all forces in the y direction. And that's going to be equal to the 10 newtons, so the north force, plus the negative of the south force, because it's going down, so we'll take the negative. Alright, from here we'll just go ahead and substitute all of our numbers in. We can start over here with the sum of the forces, because like I said, the net force for x will be placed in here for A, the net force for y is going to be placed into B, and then we'll solve for C to get the net force. So we'll start with these two equations over here. So the sum of all forces in the x direction is going to be equal to the eastern force, 16 newtons, plus negative 13 newtons for the western force. And then this equation over here, the sum of all forces in the y, when we substitute that in, is going to be equal to the northern force of 10 plus the negative southern force, 6 newtons. Alright, now at this point, to continue on and finish up with the Pythagorean theorem here, we actually have to calculate these two. So 16 newtons plus a negative 13 newtons is equal to positive 3 newtons. And then over here, for the sum of all forces in the y, the net force in y direction, is going to be 10 newtons plus a negative 6, which is 4 newtons. So we can take this 3 newtons and plug it in for A. We can take this 4 newtons, plug it in for B. So we'll have 3 squared plus 4 squared is equal to c squared. At this point, it's just a math simplification here. 3 squared is 9, plus 4 squared is 16. It's equal to c squared. So we end up with 25 is equal to c squared. And we can just take the square root of both sides, get rid of the square here. And we end up with a solution where the sum of all the forces in this problem are equal to the square root of 25, which is 5 newtons. Okay, so this again is a problem where you have unbalanced forces in two dimensions. One of the key components of these problems is going to be that you have to calculate all the forces in the x, calculate all the forces in the y, and then actually use those in the Pythagorean theorem. Okay, so let's take a look at another problem. Okay, so in this problem they say that you've been given the following forces acting on an object, and they have F1, F2, F3, and F4 on this diagram. So F1 is 20 newtons, so we'll go ahead and write it in here. Again, this will be our given step. And then we have F2 here as 110 newtons. We have F3 as 65 newtons. And we have F4 as 22 newtons of force. They tell you to calculate the mass of this object if you know that it has an acceleration of 10 meters per second squared. So another bit of information here is that this object is traveling with an acceleration of 10 meters per second squared. Alright, so the unknown in this case is the m, or the mass. You guys know that the equation for mass is mass equals the sum of all forces divided by the acceleration. To actually calculate this problem, we have the acceleration, but we don't have the sum of all forces. And since we have unbalanced forces here, we know that we're going to have to use the Pythagorean theorem to get this. So we'll go ahead and write in the Pythagorean theorem here. We also know that to get the A and the B for the Pythagorean theorem, we actually have to get the sum of forces on the x and the sum of forces on the y. So we'll have to actually use those equations. In this case, the sum of all forces in the x is going to actually be equal to F2 plus a negative F4. The sum of all forces in the y over here is going to be the F1 force plus a negative F3 force. Okay, so we'll start by solving these two net forces for the x and the y. We'll plug them into the Pythagorean theorem to get our resultant net force, and that net force will be used with the 10 meters per second squared to get the mass. That's why we had to put all those equations. So let's go ahead and start substituting again. We solve these two first. So the sum of all forces in the x is going to be equal to that F2 force, which is 110 newtons. We're going to add the negative 22 newtons from F4. The sum of all forces in the y direction is going to be equal to the F1 force, 20 newtons, plus the negative F3 force, which would be 65. And we'll have to solve these before we can move on to the Pythagorean theorem, so let's go ahead and do that. So the 110 newtons plus a negative 22 newtons will give you 88 newtons. And then 20 newtons plus a negative 65 newtons will give you negative 45 newtons. So we'll plug these two values in for A and B to get the resultant vectors. So it's going to be, will be 88 squared plus negative 65 squared is equal to c squared. Alright, so from here we'll go ahead and calculate this. 88 squared is going to be 7,744. And we'll add that to the negative 65 squared. Make sure that you, sorry, negative 45. We missed that. This is negative 45. So negative 45 squared, again, I'm getting that negative 45 from there. So the negative 45 squared ends up being 2,025. Make sure you put this in parentheses when you square it, otherwise you'll get a negative value here and that'll mess up your answer. From here, we'll add these two and you'll get 9,769 is equal to c squared. Take the square root of both sides, and you end up with c being equal to 99 newtons. Again, c is representing this sum of all forces here. So we'll go ahead and finish up our substitution step up here with this last equation. So it'll be mass is equal to the sum of all forces, which is going to be the 99 newtons, divided by acceleration, which is going to be 10. So our solution step here, our mass is going to be equal to 9.9 kilograms. Okay, so basically took what we learned about calculating net force and just added another step to calculate the mass. So you can see these problems get a little bit more complicated, and you're going to have to actually do some work in terms of drawing a free body diagram, what forces are acting on it, and then from there deciding what the net force is, so you can make some calculations on mass and acceleration for that object. Okay, so the final problem that we'll be going over today is for a boy that's dropping a parachute soldier from a roof. They say that he has a net force up of 18 newtons, and by he we're talking about the parachute soldier. And you know he has a mass of 10 kilograms. They want to know what the force of air resistance is that's acting on the soldier. Okay, so I've already got a little box here representing the object, so we'll go ahead and write the given information here. And for the object, we know that he's got a force from gravity pulling him down. And then he has a force from air resistance going up. We know that his net force in the y direction is equal to positive 18 newtons. Alright, so this positive 18 newtons gives us kind of a hint that the air resistance is going to be larger than the force from gravity, just because when we add them together we should get a positive answer, positive 18, and we all know that up is positive and down is negative. So that's kind of a little hint as to the direction that this parachute soldier's acceleration is going. In this case it's going up, so he's slowing down. You should also know that even though they didn't put it in here in this problem, we know the acceleration from gravity, little g, is equal to 9.8 meters per second squared. And the final thing that we know is his mass is equal to 10 kilograms. The unknowns here, well, obviously we're trying to find the force of the air resistance. We also, to be able to calculate that force of air resistance for the equation here, we'll have to use the sum of all forces in the y direction, which in this case is going to be the force of air resistance plus the negative force from gravity. To actually make this calculation, we know this is positive 18. We know that we're trying to find the force of air resistance, so we're going to have to actually calculate the force from gravity. The equation for calculating the force from gravity is just F equals ma, but instead of doing ma, we'll do m times little g because it's acceleration from gravity. So we'll get the force from gravity, we'll plug it in here with the net force of 18, and we'll solve for the force of air resistance. So let's go ahead and start over here with the force of gravity. Force of gravity is going to be equal to that 10 kilograms times the 9.8 meters per second squared. And when you multiply 9.8 and 10, you get a value of 98 newtons. So that's our force from gravity. From here we can plug this 98 into this first equation. So it's going to be the sum of all forces in the y, which is positive 18 newtons, is equal to the force of air resistance plus the negative force from gravity, which is 98. So to get rid of this, we'll have to subtract a negative 9.8, 98 newtons on both sides. It'll cancel here, and we'll get a solution where the force of air resistance is equal to, drum roll, see if you guys can get this right. By taking a positive 18 and subtracting a negative 98, you should have gotten a positive 116 newtons as the force from air resistance. So we've got 116 newtons going up, and we've got 98 newtons going down. So this parachute soldier is slowing his acceleration, or he's slowing down, so his acceleration should be going up. Okay, so that concludes all the problems that you'll be responsible for knowing with regards to two-dimensional unbalanced forces for objects. What I'd like to finish up with is just to show you on this weekly agenda that okay, so like I said, we'll be going over AWARE training, and basically each one of you is going to be given a password to log into this AWARE system. Whenever we have a test on AWARE, like we're going to have one on Friday, it's going to be an exam on Newton's second law. You'll just have to click on the link when you get to class for taking the test, and when you click on the link, go ahead and click on this so you can see where it takes us. It'll take you to this page where it says Student Online Testing, and you'll just enter your student ID and your password. This will be a unique password that I give you in class today, so it's really important you do not lose it. If it ever becomes compromised, it's going to be important that you obviously change it so that no one else can modify or alter your test. If you have any questions about this stuff, please let me know. Again, just another tool for us to minimize the amount of paper we use in class. I hope you enjoyed this lesson, and I will see you later.